Our project is predicting stock price using Bayesian regression with transfer entropy. This work is done by Yicheng Chen, Hongxu Ma, and Zhenglu Li. Stock market is very important in our daily life. In this work, we build up a model to predict the stock price. To well-define the features to fit into the model, we approximate the S&P 100 stocks as a closed, highly correlated group. Then we apply the transfer entropy method to find out the correlations among the stocks. And then we adopt the method in this reference, where the authors use the Bayesian regression method to predict the Bitcoin price, and we have generalized it in many aspects. This is the workflow. First, we generate a bunch of time series with different lengths. We split them into 3 parts. In the first part, we use the k-means method to find out the centers with large variance. Then we train models on the second dataset by doing Bayesian regression to the centers. The Bayesian expectation values are treated as real features x. The y labels are just the future price. With x and y, we do linear regressions to fit the weights vector w. After that, we are able to make predictions with the third dataset. Transfer entropy is an information theoretic statistical method which measures the directional correlations between variables, that is, the reduction in the uncertainty of current y gained from the certain length history of x. The figure here represents information flow from x to y. This slide shows correlation of all stocks to Apple. The numbers on the curve represents different stock labels. In this plot, the highest correlation is from Apple itself, and the second highest correlation comes from Amgen. This slide shows the influence from Amgen to Apple with different time lag. We see that Amgen has a very large impact to Apple with a time lag of 5 minutes and 390 minutes. To validate our algorithm and code, we manually generate a simple signal, which is a sine function on top of a linear function. Our regression results predict very well the signal, and the error is quite small. For the real stock data, to smooth out the fluctuations in the original data, we pre-process the data with left-moving average of a window's length 5. In the prediction, we predict the price after time window of 5. Working on this dataset, we see the model works very well. When the original stock is losing, we are still making profit around 9% in 2000 minutes. The predicted price trend matches the real data up to an accuracy around 70%. When using the on average real price, the model does not work as good as the left-moving average data, but is still able to control loss when the stock is going down. To sum up, we have developed an effective model to predict the stock price using the combination of Bayesian regression and transfer entropy. Our model works very well in the left-moving average data. Thank you.